Interstellar space, far beyond our solar system. What a view. Billions of stars like our own sun, many with planets, many of those with moons. It's hard to know which way to go. There are infinite possibilities in every direction. Whichever way, we're going to need a serious burst of acceleration. $40 trillion kilometers from home. A 150,000-year ride in the space shuttle. And we've only just reached the first solar system after our own. Alpha Centauri. One star, and two more beyond. They're spinning around each other, locked in a celestial standoff. Each star's gravity attracting the other, their insane orbital speed keeping them apart. We're so far from home now that kilometers are becoming meaningless. We're going to have to talk in light years. A beam of light takes 1 year to travel 10 trillion kilometers. So 40 trillion kilometers is over 4 light years from home. It's crazy. Distances so vast they're almost beyond comprehension. And exciting. Who knows what strange worlds lie ahead? What we'll discover when, if, we reach the edge of the universe. "10 light years from Earth, the star Epsilon Eridani. Spectacular rings of dust and ice, and somewhere in there, planets forming out of the debris, being born before our eyes. Asteroids and comets everywhere. We could almost be looking at our own solar system, billions of years ago, with comets delivering organic molecules, water, to these young planets, kickstarting life just as they may have done on Earth. At the center of all the action, a star smaller than our sun. It's still in its infancy. Any life in this solar system would be primitive at best. There must be more mature, developed solar systems out here, but finding them is like looking for a needle in a cosmic haystack. "20 light years from Earth. Star Gliese 581. It's about the same age as our sun. And orbiting it, this planet. It's just the right distance from its sun. Any closer and water would boil away. Any further and it would freeze. Ideal conditions for life to have evolved. And if comets have struck, delivering water and organic materials, then life, complex beings like us, even civilizations like our own, could be down there right now. If there are, even at this distance, they could be tuning into our TV signals, watching shows from 20 years ago. That's how long they would take to get here.
And here's your host, Joe Jackman.
But until future generations can find a way of communicating over these vast distances, all we can do is speculate. Us and them, living parallel lives, unaware of each other's existence. Unless life has been and gone. That's the problem with comets. They're creators and destroyers, as the dinosaurs found out the hard way 65 million years ago. This is the needle in the cosmic haystack, the closest we've come to a habitable solar system like our own, but it's a chance encounter. There could be hundreds, millions more solar systems like this out here, or none at all. It's Algol, the demon star, feared since ancient times. From Earth, it appears as one star that flashes on and off. But up close, we can see in reality, it's two stars, and one is being sucked towards the other. Almost 100 light years from home. Listen. One of the first ever radio broadcasts. Just a faint whisper.
We'd appreciate it if anyone hearing this broadcast would communicate with us. We are very anxious to know how far the broadcast is reaching.
And then, silence. From here on out, it's as if Earth never existed. Any aliens living beyond here will have no idea we're there. It feels like a lifetime ago we looked up at the sky wondering where we fitted in. Now we're learning to appreciate the wonders we're seeing, not just for what they tell us about our own world. It's what they can tell us about the whole universe, its past, and its future. Deep inside our galaxy, the Milky Way. A vast celestial library, each star a book with a story to tell. The Seven Sisters. From Earth, this is the brightest star cluster in the sky. And this giant, Betelgeuse, the brightest, biggest star we've seen so far, at least 600 times wider than our sun. But this, it's not a star, not a planet. Not like anything we've ever seen. A ghostly specter, more than 1,300 light years from Earth, Orion's dark cloud. Dust and gas, so dense it's shrouding us, shutting us off from the universe outside. There, deep inside, a ball of light, pulling the dust and gas towards it, heating it up, merging into a ball of burning hot gas. Like a star, like our sun, in miniature. Inside, temperatures reach millions of degrees. So hot it's beginning to trigger nuclear reactions, the kind that keep our sun shining, making energy, radiation, light. A star is being born. Or rather, stars. Orion's dark cloud is a vast star factory. We're witnessing the birth of the future universe. We came here expecting horrors. Instead, we've discovered one of the universe's greatest wonders: star birth. Jets of gas exploding outwards at 200,000 kilometers an hour, blasting dust and gas out for millions of kilometers. It's unbelievably violent. But look at the results. Nebula, vast glowing clouds of gas, hanging in space. With no wind out here, they'll take thousands of years to disperse. We've seen some strange sights, but this, it's a masterpiece. A giant horse's head rearing up in space. Stars are born, grow up, and then what? Do they die? Do they slip quietly into the night? Or go out with a bang? Somewhere between here and the edge of the universe lies the answer. Nearly 4,000 light years further, luminous clouds suspended in space, encircling what was once a star like our sun. All that's left of it are these brightly colored gases, elements formed by nuclear fusion deep inside the star, released into space on its death. Green and violet, hydrogen and helium, the raw materials of the universe. Red and blue, nitrogen and oxygen, the building blocks of life on Earth. For us to live, stars like this had to die. The oxygen in our lungs, the nitrogen in our DNA, it was all produced by nuclear fusion in stars that died long before the Earth was even born. We are made of stellar nuclear waste. Our family tree begins here. At its heart, the ghost of a star. It's a white dwarf. White, hot. Small, but unbelievably dense. In the star's dying moments, its atoms fused and squeezed together, making it so dense that just a teaspoon of this white dwarf would weigh 1 ton. It's a chilling premonition of our sun's fate. 6 billion years from now, it will become a white dwarf. Its death will herald the end of life on Earth. It makes you wonder how many other worlds have been and gone, stories left untold, celestial books lost forever. But the greatest story of them all is still to be told. We must go back through time to the very first chapter to tell the story of how the universe began. The scattered remains of a dead star, a nebula, the Crab Nebula. We are 6,000 light years from home, deep inside a stellar graveyard. Dust and gas stretching for trillions of kilometers. It looks dead, but maybe this is just the calm after the storm. After a massive explosion, powerful enough to turn a huge star into a cloud of dust and gas. A supernova. Here it is, the eye of the storm. A spinning, pulsating star, a pulsar. Gravity must have squeezed the giant star's core down to this. It's just 20 kilometers across, making it unimaginably dense. One pinhead of this would weigh hundreds, maybe millions of tons. As it shrank, like a figure skater spinning on the spot, arms outstretched, then pulling them in, it began to spin faster. 2 beams of light, energy, radiation, spinning 30 times a second, powering the huge cloud of dust and gas. There's so much radiation here, more even than on the sun. If this pulsar got as close to Earth as our sun, our planet would be instantly stripped of life. That was easily the deadliest thing we've encountered so far. Getting a strange sensation. A feeling as though there's something bad out here. A malevolent presence. The one thing we didn't want to encounter. Impossibly black, blotting out the stars behind it. We're staring into the face of death. The remains of a giant star. A black hole. Instead of contracting to a white dwarf or a pulsar, it just kept on going, shrinking until it got so small, it's just a few kilometers across, far denser than a pulsar, and impossible to resist. Stray too close, and there's no turning back. Now we know why it's a black hole. Its gravity is so intense, not even light can escape. This asteroid, a lump of solid rock, is stretching, being dragged towards the gaping hole. Inside, there's no matter as we know it. No time, no space. All the rules of physics collapse. The asteroid is gone. Truth is, nobody really knows where. We're looking at the limit of human understanding. There could be millions of black holes creeping around our galaxy, more perhaps than all the stars in the sky, but we wouldn't see them until it was too late. Like this star, spiraling, disappearing down an invisible sinkhole. Who's to say we don't live inside a vast black hole? That the whole universe isn't inside one right now, inside another universe. Sometimes it feels like the more we see, the less we know. But we do know our galaxy is more complex and more dangerous than we ever imagined. And we're still in our own galaxy, the Milky Way. The rest of the universe still lies ahead. The wonders, the dangers, the secrets, they're out there. But first, we've got to find a way out of the Milky Way.